Very good morning to all of you. Today we are going to discuss one of the important topic, that is acidity of carboxylic acids. So how the acidity of carboxylic acids vary, how the acids acts as a acidic, why is the acidic nature of these acids. So here we will discuss. So actually the carboxylic acids are weaker acid than mineral acids. For example, we have sulfuric acid, nitric acid, hydrochloric acid, hydroiodic acid. Clear? So these are some HCl. We have different types of mineral acids, but these mineral acids are stronger than this carboxylic acid. So actually carboxylic acids, they in aqueous solution they get ionizes to give proton in the solution. The proton, for example, is a carboxylic acid. When in aqueous solution it gives carbonyl anion and gives proton in the form of H3O positive. Actually, this H3O positive is formed when this RCOH negative gives proton plus RCO negative. Clear? H positive will combines with this water and plus water, so it becomes H3O positive. Clear? So this is how the ionization of the carboxylic acid leads to the formation of carbon anion and gives a proton. So acid is in a substance which gives proton in the solution. So that is why it acts as a acid. So let us here measure the dissociation constant of acidity constant of carboxylic acids. Here we will take the concentration of the products in the numerator and concentration of the reactants and the denominator. Here is the concentration of carboxylic anion, is a concentration of H3O hydrogen ion, and this is carboxylic acid, and this is concentration of water. Clear? This will be equal to, because in the reaction you know that we know that concentration of water is 2NF, that it remains constant. So when it is constant, so we don't write here the concentration of water here. So it will be written as concentration of carboxylic anion plus concentration of proton plus न्यूमरेटर में हमें लिखना है RCOH. Clear? Because this concentration of water remains constant because it is acts in the solution. Clear? So Ka is actually K is called as acidity constant, or is also called as a dissociation constant. So dissociation, actually we measure the how fast this carboxylic acid dissociates to form this carbon anion and this proton. So how fast the ionization of carboxylic acid takes place, it is measured by a constant that's called a dissociation constant. Clear? So from this dissociation constant we measure the extent of dissociation or the extent of ionization of this carboxylic acid. Clear? So here we have seen that by comparing the values of these carboxylic acids, we have seen that more will be the dissociation constant. When the dissociation constant of the acid is more, its acidity is more. It means that it fast undergo ionization. That what it happens, that more carboxylic acid is, it gets ionizes to form RCO negative and H positive. Clear? So more carboxylate anion and proton is released in the solution. So if the dissociation constant is more, acidic strength will be more. Clear? But in terms of pK value, pK is actually is equal to the minus, it's log 1 by K, reciprocal of the dissociation constant. So in we have seen when it is a reciprocal, it is inversely proportional to, that is pKa will be inversely proportional to K, log K. Okay, clear? That is more will be the pK value, less will be the Ka value. If pK value is less, Ka value will be greater. Clear? So if from this we have seen that pK will be equal to minus log K. Clear? Because when it gets to the denominator, it becomes minus. So more the value of K, stronger is the acid. When the dissociation constant is more, acid will be more, acidic strength will be more. Similarly, when the pK value will be more, less will be the acidic. Acid strength will be less. Clear? So they are inversely proportional to each other. When Ka value is greater, this will be lesser. Clear? So how this how this carboxylic acid shows acidic nature? It is because of the following factors. First is resonance stabilize the carboxylate anion which is formed during the reaction. So this carboxylate anion, it is stabilized by resonance. Actually what happens is that when carboxylic acid gives carboxylic anion and proton in the solution, this reaction favors in the forward direction, because of the formation of this carboxylic anion, because this carboxylic anion being gets stabilized by the resonance, as a result of which more of the carboxylic groups will undergo ionization and form the carboxylic anion and proton. So more protons will be formed in the solution, hence the greater will be it is acidic strength. Clear? So it is acidic strength depends upon this. If this is the acid, this will be the conjugate base. If conjugate base is strong, weaker will be acid. If conjugate base is weak, stronger will be acid. So here we will see that whether the conjugate base formed here, if is it strong or strong or weaker. So if it will be stronger, then it means that reaction will be in the backward direction. More of the carboxylic ions will be formed. Clear? So if it conjugate base is weaker, then it will be in the forward direction. That is more will be the carboxylic anion formed. Conjugate weaker means that it has less availability of lone pair of electrons. So लेस अवेलेबिलिटी ऑफ लोन पेयर ऑफ इलेक्ट्रॉन्स कब होगी? जब ये स्टेबल होगा, यानी जब व्हेन कार्बोक्सिलिक आयन मोर स्टेबल होगा, it does not have to lone pair of electrons to donate, as a result of which it acts as a weak conjugate base, because it is more stable and it has less availability of lone pair of electrons. So less weaker will be the conjugate base, stronger will be the acid. So actually what happens here, that carboxylic acid gives carboxylic anion gives and proton. When we compare the resonance structures of the carboxylic acid with the carboxylic anion, we will see here that during formation of the resonating structures, you will see that it's a resonating structure first and resonating structure second of the carboxylic acid. Here the shifting of electrons takes place from this oxygen for here conjugation. Because of conjugation they undergo shifting, as a result of which this oxygen will carry the negative charge here, and this oxygen will carry positive charge here. Clear? Because now it contains three covalent bonds. As a result, this oxygen will carry the positive charge here, because it becomes electron deficient. So we will see here that there occur the separation of charge. This oxygen carrying negative charge, this oxygen carrying positive charge. So this charge separation destabilizes this carboxylic acid anion. Clear? Its resonance structure will be like that. That is, this pi bond will under conjugation will resonate between three atoms, oxygen, carbon and oxygen. This oxygen will carry negative charge, this oxygen will carry positive charge. Clear? So here this oxygen carry negative charge, this carry positive charge. So this destabilizes this resonating structure, because the oxygen carrying positive charge, this does not favor the formation of carboxylic acid. So here the carboxylic acid tends to lose this proton in order to accumulate more negative charge on this. So in order to compensate the charge on positive charge of this oxygen. So as a result of here, we will see here that resonance structure of this carboxylic anion, this hybrid structure is less stable, because this oxygen carry positive charge, and being electronegative it carries positive charge, and there occur charge separation. So there are two reasons that this carboxylic acid resonance hybrid become less stable, because there occur charge separation, positive and negative charge separation. So when we discuss the rules of resonance structure, resonance, we will see here that more will be the charge separation, less will be the stability. As a result, this will be less stable. And second factor is that this oxygen carry positive charge, being electronegative. When more electronegative atom carry positive charge, then it will be less stable. Clear? So these are two factors which destabilizes this carboxylic acid resonating structure, resonating hybrid. Clear? So this hybrid is less stable. But when we take the case of carboxylic anion, so here is a carboxylic acid with proton with hydrogen, but there is, when this proton gets released, it forms the carboxylic anion. So we will see here that whether this carboxylic anion is resonance stabilized or not. So if we see here that due to this conjugation, the this lone pair of electron and conjugation result in the formation of this resonating two resonating structures here. So this oxygen will carry, for by the shifting of this pi bond to this oxygen will carry negative charge, and this oxygen will does not carry any negative charge, but it does not also carry any positive charge here. But under resonance structures, under resonance hybrid, we will see here that this actually this bond, if we see that, if we made a second resonance structure of this, we will see here that this oxygen will carry the negative charge. This again comes in, this again shifts the electron pairs to this carbon. As a result of this, again carries negative charge. So as a result, we will see here that this pi bond or negative charge gets comes under resonance with three atoms, that is carbon, oxygen, and oxygen. Clear? As a result, due to this result in the formation of this resonance hybrid. But this resonance hybrid is more stabilized, because this oxygen carries negative charge, being electronegative. This also carries negative charge. So due to which there is no positive to negative charge separation, so this is more stabilized. Also because there is negative charge is present on the more electronegative atom, so this gets more stabilized. So it is due to this fact that when carboxylic acid gives proton, and it forms a carboxylate anion. So this carboxylic acid will tend to, because of the stability of this carboxylate anion being resonance stabilized, more carboxylic acid tends to become carboxylate anion and gives proton. So as a result of more acidic strength will be more. Clear? So because of the conjugate base is more stable, as a result of this acidic strength, this acid will tend to lose this proton and to form this carboxylic anion. तो इस स्ट्रक्चर में ये जो है कार्बन आयन मोर स्टेबल बन जाता है एज कम्पेयर टू दिस. एज अ रिजल्ट इसकी टेंडेंसी ये रहती है कि प्रोटॉन को लॉस करे और दिस कार्बन आयन की शक्ल में आ जाए, यानी कि दिस बिकॉज ऑफ द स्टेबिलिटी ऑफ दिस रेजोनेंस हाइब्रिड of the carbon anion, this carbon acid gives proton readily, hence acts as a acid. So there are factors which affect the stability of the carbon anion. The first is there does not occur in charge positive or negative charge separation here, and negative charge is present on the more electronegative oxygen atom. So we have already discussed this. So here now we will see here the effect of substituents. There are two types of substituents present in the particular compound. They may be electron releasing substituents, which shows plus I inductive effect, and second is the electron withdrawing substituents, which shows minus I effect. Clear? So first let us first discuss the substituents which are having plus I effect, and that means these are having plus I inductive effect. Plus I inductive effect means they are tends to decrease the acid strength, because we know that when the acid carboxylic acid gives after ionization it gives RCO negative ion and H positive, and we have seen that this carbonyl anion carrying negative charge on these oxygen atoms in the resonance hybrid structure. So if this carboxylic acid group is attached to the electron releasing substances, so they will intend to increase the electron density on this carboxylic acid, clear, carboxyl anion, as a result of which their acidic strength gets decreases. So we will see here actually what happens here. If for example there is a CH2H5 group attached to this carboxylic acid group, for example here is carboxylic acid, and after when it gives up when it loses the proton, it becomes carbon anion. Here there is a negative charge. So if we know that this C2H5 being electron releasing substance, it shows plus I inductive effect, plus I inductive effect, plus due to plus I inductive effect they tends to give electron density, they are tends to release the electron density towards this carbon atom, towards this carbon atom, and then towards this oxygen, as a result of which more this they will tend to increase more electron density to this already to this oxygen atom which is having already negative charge. So when this alkyl group attached to this carbonyl anion, so this alkyl group showing plus I inductive effect, they tends to increase the electron density on this or these oxygen atoms which are having already negative charge, as a result of which they destabilizes this decreases the stability of the carbonate anion. So more or a number of electron releasing substance present on a particular acid, less will be its acidic strength. So here we have seen that increasing electron density on oxygen atom, the release of the H positive ion becomes difficult. So it also indicates that when electron density on the carboxylic acid, for example, when electron density gets increased on these oxygen atoms, as a result of which it does not lose this proton easily. This is another reason, and first reason I have already discussed you. I have already explained you that the carbonyl anion gets less stabilized because of the accumulation of more negative charge. So electron releasing substance tends to accumulate more negative charge on the this carboxylic anion, and the result of which this decreases the acidic strength of the particular acid. Clear? So there are two reasons. So first reason is electron density increase on oxygen atom, as a result of which H positive ion becomes difficult to release. First thing. Second, also increase the electron density on the carboxylic anion, which decrease its stability. Clear? So plus I inductive effect groups substances when present on the particular acid, they will tend to destabilize or decrease the acidic strength of particular acid. The more the electron releasing substances, less will be its acidic strength. So we have seen here, we have compared the following. Sorry, this is the relative acidic strength of some molecules. For example, we have formic acid, which does not have any electron releasing group. It is heterogen, does not have any it does not shows much of the plus I inductive effect. The plus I inductive effect is shown by most of the alkyl groups. They show the plus I inductive. For example, here is a methyl group attached to this COH, but here it is C2H5 COH. So it shows more plus I inductive effect. After that is C3H7 at a group attached to this carboxylic acid group. As a result, this tends to accumulate more negative charge on this carboxylic acid as well as a carboxylic anion. So as a result, this will be less acidic as compared to this because and this will be less acidic as compared to the acetic acid, which will be less acidic as compared to formic acid. So formic acid, which does not carry any of the alkyl group, is more acidic than that of the acetic acid, which is more which is more acidic than that of propanoic acid, which is more acid than that of butanoic acid. Clear? So this is how the acidic strength varies by electron releasing substituents. Similarly, there are electron withdrawing groups, which the electron withdrawing substituent shows minus I effect. They tend to decrease the electron density on this oxygen atom. For example, if there is some group X, which is electron withdrawing group, they tend to withdraw the electron towards itself. They attract the electron pairs towards itself. As a result, for example, here we have one hydrogen here. So this being electron withdrawing, they tend to decrease the electron density on this oxygen atom, as a result of which this oxygen carrying negative charge. So here the negative charge gets shifted toward this electron withdrawing substituent, as a result of which this proton gets easily released. Clear? So electron withdrawing substituents increase the acidic strength because more of the negative charge will get shifted towards this electron withdrawing substituent, as a result of which this proton gets easily released from this acid. Clear? Second thing, after the donation of the proton, it gives RCO negative. Clear? And H positive. This RCO negative, when the if this is attached to some of the group which is electron withdrawing group, so this carbon anion, the electron density will be shifted toward this electron withdrawing group, as a result of which it gets more stabilized. So negative charge will get dispersed toward this electron withdrawing group, as a result of which this conjugated base becomes stabilized and it acts as a weaker conjugate base. Clear? So as a result, this gets stabilized due to the presence of electron withdrawing group. So we have seen here that first, electron withdrawing substituents, electron withdrawing substituents showing plus I inductive effect tends to increase the acid strength. First, by decreasing the negative charge on oxygen atom, hence release of H positive ion becomes easy. That is favors the carboxylic anion formation, as we have already discussed, that carboxylic anion carrying the negative charge on the oxygen atoms, as a result of which when the electron withdrawing group is present, more of the negative charge will be dispersed towards the electron withdrawing group. Or in other words, we may say that accumulated negative charge which is accumulated on the oxygen atom will get more dispersed towards this electron withdrawing group. So acid strength is influenced by the following factors. First factor is nature of electron withdrawing group. If the electron withdrawing group is strong, then acid will be more strong. The more the electron strength of electron withdrawing group, more will the strength of acid. Similarly, position of electron withdrawing group. What will the position of electron withdrawing group? It also affects the nature of acid strength, and also the number of electron withdrawing groups. How many number of electron withdrawing groups are present in a molecule? This will also affect the acidic strength. So we have here we have discussed here, if there is only one electron withdrawing group present, so this will be more acidic as compared to the this electron withdrawing group is present at alpha carbon atom, so that of the carbonyl group, as a result of which is very close. This is very close to this carboxylic group. As a result, more of the electron density will be dispersed towards this electron withdrawing group. Clear? Hence, it decreases the electron density on this oxygen atom. Clear? Second, in second molecule, we will see that this electron withdrawing group is present at beta carbon. This alpha carbon, this beta carbon. So it is somehow distant from the carboxylic acid group. जिसकी वजह से क्या होता है, जब ये इससे बहुत ज़्यादा थोड़ा दूर है, जिसकी वजह से इसका इफेक्ट थोड़ा कम होता है. एज रिजल्ट ऑफ विच इट इज़ एसिडिक स्ट्रेंथ जो होती हैं वो कम होते हैं एज कम्पेयर टू दैट ऑफ दिस. तो इसके एसिडिक स्ट्रेंथ कम होती हैं बिकॉज ऑफ द पोजिशन ऑफ द क्लोरीन एटम जो होते हैं वो थोड़ा दूर है, वो दैट इज़ प्रेजेंट एट द बीटा कार्बन as compared to that of this molecule is present at the alpha carbon, and this is very nearer to this carboxylic carbonyl group, due to which, as a result of which, more electron density, this will, it is effective will be more as compared to that of this electron withdrawing substituent. Similarly, we will here discuss number of, when there are different number of electron withdrawing groups. So here in the first molecule we will see there are 3 electron withdrawing substituents present on the particular molecule, as a result of which this will be more this, it is acid strength will be more as compared to this molecule which is having only 2 electron withdrawing groups. It is acid strength will be more as compared to that of the molecule which is having only 1 electron withdrawing group. Clear? So it is acid strength also depends upon the position and also the nature of electron withdrawing group and number of electron withdrawing groups. So in short, we may conclude here that electron releasing groups tends to decrease the acidic strength. Similarly, electron withdrawing groups tends to increase the acidic strength. Electron releasing groups tends to increase the negative charge on the carboxylic acid or carboxylic anion. Electron withdrawing groups will tend to decrease the electron density on the carboxylic acid or carboxylate anion. Clear? This is how the different nature of the substituent will affect the its acidic property. Hope you understand.